Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Farisa Yuni binti Muhammad Jami'an and my student ID is 2020896156.
Hi, Assalamualaikum. My name is Nurin Azira Damia binti Muhammad Fazli. My student ID is 2020858638.
Assalamualaikum. My name is Hasha Huri Ain binti Kamar Zaman. My student ID is 2020827148.
Hi and Assalamualaikum. My name is Nur Shafni binti Muhammad Ashraf. My ID number is 2020469036.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nuridayu binti Idrus. My matric number 2020851938.
We are going to discuss the topic about apply maximum and minimum problem under application of differentiation. First, let me explain briefly about differentiation. Differentiation is a technique which can be used for analyzing the way in which functions change. This is a technique used to calculate the gradient or slope of a graph at different points. Differentiation in mathematics is the process of finding the derivative or rate of change of a function. In terms of functions, the rate of change of a function is defined as dy dx equals to fx equals to y prime. In particular, it measures how rapidly a function is changing at any point. In contrast to the abstract nature of the theory behind it, differential practice techniques can be performed with algebraic manipulation alone, using 3 basic derivatives, 4 rules of operation, and knowledge of how to manipulate functions. In general, scientists observe changing systems or dynamical systems to obtain the rate of change of some variable of interest, incorporate this information into some differential equation, and use integration techniques to obtain a function that can be used to predict the behavior of the original system under diverse conditions. Geometrically, the derivative of a function can be interpreted as the slope of the graph of the function, or, more precisely, as the slope of the tangent line at a point. Its calculation, in fact, derives from the slope formula for a straight line, except that a limiting process must be used for curves.
In this topic of applied maximum and minimum problems, the process of finding maximum or minimum values is called optimization. We will be determining the absolute minimum and or maximum of a function that depends on two variables given some constraint or relationship that the two variables must always satisfy. We are trying to do things like maximize the profit in a company, or minimize the cost, or find the least amount of material to make a particular object. Before we can use calculus techniques to solve these maximum or minimum problems, we need to understand the situation at hand and translate the problem into mathematical form. After solving the problem using the techniques, we need to check that our solution really solves the original problem. Often, the most challenging part of this procedure is understanding the problem and translating it into mathematical form. In this section, we examine some problems that require understanding, translation, solution, and checking. Our objective is to calculate the dimensions in order to minimize the cost of the garden.
So the problem statement is, Datin Vida wishes to enclose a rectangular garden with an area of 250 feet square on one side by a metal fence costing Rm 38 ringgit per meter and the other side by a brick wall costing Rm 50 ringgit per meter. What dimensions should the garden have in order to minimize the cost and the minimum cost? A. Find the dimensions that will minimize the cost. B. Hence, find the minimum cost.
For solution A, step 1, we label the quantities relevant to the problem on the figure.
For the length of the rectangular garden, we label as X, and the width we label as Y, and the cost of the brick wall is 50 ringgit, while the metal fence is 38 ringgit. Step 2. We find a total cost and the area of the garden. Total cost equal to 50x plus 50y plus 50x plus 38y. The total is 100x plus 88y. Why? The area of the garden is 250 feet square. So it means xy equal to 250, and y we will get 250 divided by x. So we will substitute the y into the total cost. It means 100x plus 88 multiplied by 250 divided by x. We will get 100x plus 22,000 divided by x. Step 3. We will find the derivative as a critical point. The derivative is 100 minus 22,000 x with the power of negative 2. It means 100 minus 22,000 divided by x square. Step 4. Let the derivative equal to 0 to find the critical point. It means 100 minus 22,000 per x square equal to 0. And we will get 100 equal to 22,000 divided by x square, and we will multiply by x square, and we will get 100x square equal to 22,000. X square will get 220 when we divide the 22,000 with 100. So we square root the 220, and x equal to 14.832 feet.
When we get the value of x, we need to test the value first by using second derivative test. Substitute the value of x that we obtained from the equation above using the formula 44000 divided by x cubed. The answer that we got is 13.485. This indicates that the value of x is minimum value. This is because it is greater than 0. After that, we must substitute the value of x to get the value of y. The solution for value y is 16.855 feet. If we use the following equation, which is 250 divided by 14.832. So using the formula, 100 multiply with 14.832 plus 22000 divided by 14.832, we can compute that the total cost of the garden. And the answer is that the garden's minimum cost is Rm 2,966 ringgit and 48 cents.
Based on the solution that we showed, we achieve our objective, which is to find the minimum cost that Datuk Vida should know to enclose her rectangular garden. This shows that we can interpret the meaning of derivative, the importance of derivative, and solve the maximum and minimum problems. It is easier for us to know and calculate the minimum cost when we use this method as our solution based on the problem statement that we chose. This can be said that the technique of differentiation in applied maximum and minimum can be used for solving problems and can be applied in our daily life. In conclusion, we would like to thank our lecturer, Madam Jasmani binti Bidin, for giving us an opportunity to do this project and always gave us encouragement throughout the process of completing this. Not to forget, thank you also to all the members in this group for working together to complete this project. To be honest, everyone in this group showed enthusiasm and was very committed to completing this assignment. Despite all the obstacles we faced, we managed to settle down this project. So that's all from our group. We hope it helps and thank you for watching. Have a nice day everyone. Assalamualaikum.